Alright, this lesson continues on from solving polynomials. However, now we're going to be adding in complex and irrational zeros. So not just whole numbers, now we're going to add in more to these. So before I get on, I want to do a couple review on solving and simplifying complex and imaginary numbers. For example, my first example is 5x squared plus 120. Subtract 120. You get 5x squared equals to negative 120. You can divide by 5. And you get x squared equals to negative 24. And then you take the square root. Now when you take the square root, you must add a plus or minus in the front. So I get that x equals plus or minus radical negative 24. Now that's going to be split up. And I can do the factor tree here. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. Pairs will go on the outside. The solos will be multiplied back into the inside. So this becomes x equals plus or minus. The pair was a 2, so only one goes out. And on the inside, it's 2 times 3 would be 6. However, there's something else we need to remember. I have a negative here. And a radical of a negative 1 equals I. So I have my answer of x equals plus or minus 2I radical 6. Number 2. We're going to simplify this. And I'm going to start with the radical of 28. So 28 is 2 and 14. 14 is 2 and 7. That's all I have. Pairs go on the outside. Singles go back on the inside. So x equals a negative 10 plus or minus 2 radical 7 all over a negative 4. Now, I have a negative 10, a 2, and a negative 4. My whole goal is to simplify that as much as possible between those three numbers. And since the negative 10 is in the front, I know that I can simplify by 2. However, since the 10 is negative, it's actually going to be simplifying by negative 2. So negative 10 divided by negative 2 becomes 5. 2 by negative 2 is a negative 1. And negative 4 by negative 2 give me a positive 2. So here's what I have. Now one last thing to simplify is this piece here. And the reason is, if I have plus a negative 1, that just means I have a negative 1. If I have minus a negative 1, that means I have a positive 1. So the reality is I still have a plus or minus 1. So that negative isn't even needed. This one right here. So my answer would be x equals 5 plus or minus. If it's just a 1, it can kind of disappear. So it can be like this over 2 or like this. And for my last one to review, x equals 9 plus or minus radical negative 27 over 3. Factor tree. The negative 27 I'm going to split up into be a negative 1, and then I'm going to split up to be 3 times 9. The 9 is 3 and 3. So pairs go on the outside. Singles go back in. And that negative 1 becomes an I. So if I write it out loud, I get x equals 9 plus or minus, the pair comes on the outside, the I goes on the outside, and on the inside is a 3, the single, all divided by 3. So now I need to simplify the 9, the 3i, and the 3. And I know that what goes into those three numbers are going to be 3. So 9 by 3 is 3. 3i by 3 is just 1i, or I. And 3 by 3 is 1. So I get a final answer of x equals 3 plus or minus I radical 3. Okay, now for the new stuff. So we're going to solve these problems, but we're going to get something that's big, kind of like this one in example 1. And we can actually search for the possible rational roots first. Yeah, that word over here says first. And that is done by doing this step here. You find the factors of the constant term divided by the factors of the leading coefficient. And I'm going to show an example of this to make sure you understand what that means. Then you can use synthetic division to confirm rational zeros. Since roots are also x-intercepts, a graph can help choose likely roots or likely zeros. So I'm going to show you a full thing of what this actually means. Example 1. Find all the zeros of f of x equals x cubed plus 3x squared plus 2x plus 6. So first step is factors of the constant. This is my constant. Factors of 6 are 1, 2, 3, and 6. But they are also all the negatives of those, so we're going to do plus or minus each of these. So now we have to do factors of the leading coefficient, which is this number here. In this case it's a 1, so it makes it easy. The factors of 1 are just plus or minus 1. The possible zeros are all of these divided by all of these. So 1 divided by 1 is a plus or minus 1. That was this here. Then I'm going to go 2 divided by 1, which will be plus or minus 2. Then I do 3 divided by 1, plus or minus 3. And lastly, 6 divided by 1 is plus or minus 6. So the reality is we have 2, 4, 6, 8 possible zeros to try. And if you were to try all 8, only 3 would work. And I know that because I have degree of 3 here. So you're going to have a lot of chances to actually mess up. However, it says, since roots are also x-intercepts, a graph can help choose likely zeros. Let me show you what that means. So I typed in my polynomial, which was x cubed plus 3x squared plus 2x plus 6, into desmos.com/calculator. And I'm looking along this line here to see numbers that come close to what I have. And really it's only this one here, which is a negative 3. So if I go back, out of all of these, the only number I'm going to try is going to be this one here, a negative 3. Because that's where I see it crossed. So wherever it crosses the x-intercept, that's where it's going to be. So to solve these, we're going to do synthetic division. And let's say you don't have a graphing calculator or you don't have access to the internet for Desmos, you're going to have to just start guessing and checking and trying them all to find which ones work. So with the negative 3, Synthetic division. That negative 3 now goes in this box. And for synthetic division, I find the coefficients of these terms here. 1, 3, 2, and 6. And so I solve. You multiply, you add down. You multiply, you add down. You multiply, you add down. Since it gives me 0 here, that means that it is a factor, so I'm good. So I am left with 2 plus 0x plus x squared. And 0x isn't even needed, so I'm only left with x squared plus 2. Alright, so far I have x plus 3, that comes from this, and I have x squared plus 2. So since I know these, I want to set it equal to 0 and solve for all of my zeros. Solve for all of my roots, all my solutions. So this becomes x plus 3 equals 0. Subtract 3, x equals negative 3. This becomes x squared plus 2 equals 0. Subtract the 2, x squared equals negative 2. Square root, plus or minus, and solve. And I don't want to keep the negative inside, so this actually becomes x equals plus or minus I radical 2. I have 2 roots here, plus 1 root here, gives me 3 roots. I started with a degree of 3, therefore I have found all my roots. Alright, next problem. Factors of the constant. This is my constant. My factors are, since it's 4, it's only going to be plus or minus 1, plus or minus 2, plus or minus 4. Because 1 times 4 equals 4, and 2 times 2 equals 4. Next, factors of the leading coefficient. That is 2. Therefore, it is only plus, minus 1, and plus or minus 2. So I'm going to look at a graph to kind of, well, before I look at the graph, let's kind of list all the possible zeros. 1 divided by 1, 2 divided by 1, and 4 divided by 1. Then I'm going to go 1 divided by 2, 2 divided by 2, and 4 divided by 2. However, 2 divided by 2 is 1, and I already have 1, so I can cross this out. 4 divided by 2 is 2, so I already have 2, so I can cross this one out. So I have 2, 4, 6, 8 possible zeros again. I'm going to look at the graph to kind of see what it would be. And I'm seeing a negative 4 and a 1/2. However, just because I found on the graph, I still need the work to prove it. So I'm going to start with the negative 4. Let's make a note of that graph. Shows negative 4 and 1/2 as possible zeros. So I'm going to do negative 4 first. Negative 4 with 2, 9, 5, 3, and negative 4. Multiply, add, multiply, add, multiply, add, and multiply. That gives me 0, which means it is a factor. This leaves me with negative 1, 1x, x squared, and 2x cubed. Since it showed me that this is also a possible zero, I'm going to now use 1/2 for this step here. So let's use a different color, and that will be 1/2, 2, 1, 1, -1. 2, 1/2 times 2 is 1. 1 plus 1 is 2. Half of 2 is 1. 1 plus 1 is 2. Half of 2 is 1. -1 and 1 makes 0. So this one here on top gives me x plus 4. It's the opposite of what's in the box. This one here gives me x minus 1/2. I'm going to put or x equals 1/2 as a solution, or x equals -4 as a solution. So then I'm left with this. Because I'm not done yet. I only have 2 out of 5. Sorry, 4. So I'm left with this. 2 plus 2x plus 2x squared equals 0. You can try the super x, but it will not work. So it's not factorable normally. Therefore, we must go to the quadratic formula, which says x equals -b plus or minus the square root b squared minus 4ac all over 2a. Where 2 is my a, this 2 is my b, and this 2 is my c. I'm going to simplify. -4 times 2 is -8 times 2 again, -16. All divided by 4. I'm going to keep going. -2 plus or minus radical -12 all over 4. -12 can be 4 and 3, 2 and 2. So pairs on the outside, this goes back on the inside. Don't forget that it's negative. I'm pulling out a 2i, the radical 3 on the inside, all divided by 4. Last step is to simplify. And so I get x equals -1 plus or minus I radical 3 all over 2. I have 2 solutions here, the plus and the minus. Another solution here that makes 3, and the last one here makes 4. So those are my 4 solutions.